Hello, this is Ms. DB. In this video we are going to look at graphs of absolute value functions. So they have absolute value functions have one of the most interesting looks about them. If you start to graph an absolute value function, let's look at some values that you could plug in for x. So when you put in x equals -2, you take the absolute value of it, you get +2. And the absolute value of -1 is 1. Absolute value of 0 is 0, absolute value of 1 is 1, and 2 is 2. So when you graph them, you get this sharp V shape. Each side of the absolute value function is a line, it's linear, but together they make up an absolute value function. So there's some things to know about this. There's a vertex. The vertex is the sharp point where it turns. So if you were going downhill from here to here, and then you stop, and then you start going uphill, that point is the vertex. So this is the parent function, the original, the most basic absolute value function you can have, y equals absolute value of x, or f of x equals absolute value of x, and that's vertex is at 0, 0. Now through the vertex there's a line of symmetry here, and that's called the axis of symmetry. You can write the equation of that axis of symmetry. We won't do it in this lesson, but in the future you will be writing equations of axis of symmetry, and it would just be x equals 0. It's a vertical line. It goes through x equals 0, so its equation is x equals 0, not 0, x equals 0. We'll be finding the domain and range of our functions, the domain of the parent function, and for all absolute value functions, unless they have some limit on them given to you, is all real numbers. Because x can be all the negative numbers, it can be all the positive numbers. So the domain is going to be all real numbers almost always, unless you're told that this is a real world thing and it can't have anything less than -5 or something. But if nothing is given to you to limit that, it's just all real numbers. The range is different though. You can see that for this one, the range is all positive numbers and 0. So we would write that the range is y is greater than or equal to 0. It can be 0, and then it can be all numbers greater than 0. X and y intercept, sometimes they ask that. In this case, they're both 0. That's the point where it's touching the x-axis, and it would go through the y-axis or touch the y-axis at that point as well. You can graph them by hand, and here's one that's a little bit more complicated, by picking values and plugging them in. If you do them by hand, make sure that you pick some negative numbers and some positive numbers so you can see what's happening on your graph. And then again, you'll be looking for the vertex, the domain, and the range is what we're going to be focusing on in this section. Also, let me just mention that in both of these examples, the vertex is the minimum value on the graph. Sometimes your absolute value functions will be flipped over, they'll be upside down, and then you would have a maximum rather than a minimum. I'm going to see if I can find one that would have that. These are, oh, here we go. Number 4 is going to be flipped around. So we could write a table of values if you want to do this by hand to practice. And we'll pick some values for x on the negative side, and we'll pick some on the positive side. And then we'll check this in Desmos. So my function is negative absolute value of 3x minus 4. So I would replace the x with -3, and then take the absolute value of it, and then take the negative of it. So 3 times -3 is -9, and the absolute value of -9 is 9. So we'd have -9 minus 4, so -13. And then I'll repeat this for -2. I'm just going to use the same place. So 3 times -2 would be -6, and I take the absolute value and I get 6, but then I have to take the negative of it. So -6 minus 4 is -10. And then I want -1. So 3 times -1 is -3. Take the absolute value, I get 3, but the opposite of that is -3. So that's -7. 0 is going to be a little easier. 3 times 0 is 0, so I just have -4. And then I'll take some positive values. So at 1, I would have 3 times 1 is 3, and then the absolute value of 3 is 3. Take the opposite of it because of this negative. -7, and you can see there's kind of a symmetric pattern going here again. And then I'm going to let x be 2. So at 2 I'd have 3 times 2 is 6. The opposite of 6 is -6, minus 4 is -10. And then at 3 we would get 9, so I'd have -9, minus 4 is -13. So you can see that these are matching up. So when I graph these, I'd have -3 is at -13 down here. -2 is at -10. -1 is at -7. 0 is at -4. And then 1 is also at -7. 2 is at -10. And 3 is at -13, a little bit off of the screen. So if I'm just going to sketch this, it's an upside down, like I was talking about sometimes that. So my vertex is right here. There's my vertex. So my vertex is at 0, -4. It's not always at 0, but in this case it is. That would be a maximum point if you were asked to find that. The domain, again, I can use any values for this, so it's all real numbers. Now look at the range. My y values are always less than my maximum of 0, -4. So my range is that y is always less than or equal, in this case, because they're always down here. They're always below this line. So y is less than or equal to -4. Now I said we could check this in Desmos. Let me show you how to do that. And some of you may prefer just to go ahead and graph these in Desmos. In Desmos, you're going to type in exactly what you see. And to find the absolute value, you need the keyboard in Desmos. So the keyboard that you want is way over here. It says functions. And we need, I don't know if you can see all this, at the very far is miscellaneous. Did I click it? I have to find where the absolute value function is. Not there. I don't think it would be under stats. It should be here, but I don't see it. I might be looking right at it and missing it. Is it on here? Oh, it's right here. Look at that. So in Sketchpad, it's a little bit hidden. But in Desmos, they have it right here. So we have the absolute value of 3x. And then I can click the right arrow to move out of the absolute value. And then I need to do -4. So it's a little bit low down, but there's the graph. It looks like mine. So I know it's right. You can also, there's linked in your assignment, this absolute value, which is already set up for you. The only thing is the y is on the opposite side. I can change that. If you want to change it, you can. Put the y over here, and I'll just, doesn't need two of them. Okay, so what you would do on this is you would make it match this. So we want m to be 3. Going the wrong way. And we want b to be 0. And we need to adapt this a little bit because we don't have, we need a -4 on there. And then we would need a negative in front. So it's pretty much the same thing as I did on the other one, except there's some stuff already set up for you so that you can adapt it as need be. So either start a new one or you can adapt this one as you go. And then remember, in Desmos, you can either get a screenshot, of course, but you can also get a link by clicking on Share Graph and then copy this. And then you would paste this into your worksheet. If you paste this into your worksheet, it's not a live link until you hit the space bar. Then it turns into something that I am able to click on and able to see just from clicking on it. Doesn't look like it worked on mine. Usually that's what it takes to get it to be an actual link. There it goes. See how it turned blue and underlined? Now that means that when I open your worksheet later in Blackboard, I can just click on it and see what your graph looks like. So it makes it a lot easier for me. All right, so on these problems, you're going to do the same thing. Graph them. Tell me what the vertex is, what the domain is, and what the range is. You can attach a screenshot of your graph or a screenshot of your graph, or if you make them in Sketchpad, you can just attach the files separately. If you're going to attach your images separately rather than pasting them into the worksheet, please make sure that when you save them, you're numbering them, like number 5, number 6, number 7. Otherwise, I don't know which one is which when I get your work. It's easier if you just paste the link here or your screenshot right after the problem. Much easier to grade. All right, then there's some questions. You're going to look back and see if you can figure out some rules about absolute value functions, about what a negative in front will do, like if it's upside down or reflected over the x-axis, what the domain will always be, what happens if when you multiply by a number greater than 1, and will it be wider, will it be skinnier? Let's look over here. What if I multiply this by a number? I'm going to take the negative away for now. If I have this function here and then I multiply it by something like 4, is it going to make it skinnier or wider? It made it skinnier. What if I multiply it by like 0.5? It made it wider. So you can experiment and see what happens to answer these questions at the end. And then there's some bonus questions about vertex form of the absolute value function. See if you can figure out from an equation what the vertex will be. So here's an example with H and K in there, which are letters that you would use in your vertex, and here's an example with numbers. And you can play around with this a little bit and see if you can figure out how to figure out what the vertex is from an equation. That's bonus questions. All right, that's it for today. Let me know if you have any questions. Thanks a lot.